Part of the James Webb Space Telescope has changed the way humanity looks at the universe. With its extraordinary sensitivity, it can analyze the chemical fingerprints of atmospheres light years away, breaking starlight into subtle signatures that reveal what worlds are made of. When Webb examined the atmosphere of the distant exoplanet K2-18b, it detected molecules that, on Earth, are strongly associated with biological activity. While no scientist claimed this as proof of life, it marked one of the most compelling steps yet toward answering the question humanity has carried for centuries: are we alone? Yet far closer to home, another Webb observation quietly unfolded into something far more unsettling. The order arrived through the Deep Space Network without ceremony. To the outside world, nothing appeared unusual. But inside a sealed chain of control rooms, the mood shifted instantly. Engineers who had listened to Webb's daily telemetry like a familiar heartbeat sensed something was wrong. This was not the silence of routine maintenance. It was the silence of restraint. A silence imposed. Rumors moved faster than official notices. Webb had spent several observation cycles focused on Mercury. On paper, this was unremarkable. Mercury is difficult to study because of its proximity to the Sun, but Webb's infrared instruments are uniquely suited to cutting through that glare. Previous missions had hinted at unusual temperature variations, but nothing that challenged planetary science itself. Webb's data did. The first anomalies appeared as infrared signatures that refused to align with any known geological explanation. They were not volcanic. They were not magnetic. They were not artifacts of instrumentation. As the scans continued, patterns emerged. Not random ones, but structured forms etched into thermal gradients. Parallel ridges reflecting heat in synchrony. Angular depressions forming precise geometries. These features stretched across hundreds of kilometers and persisted through repeated passes, unaffected by Mercury's extreme day-night temperature swings. Some scientists argued the signatures could be exotic mineral layering responding to solar radiation in unusual ways. Others felt a deeper unease. Nature can produce patterns, but rarely ones so orderly, so persistent, and so mathematically consistent. Mercury, a planet believed to be geologically dead for billions of years, was behaving as though something beneath its surface still followed a design. Closed-door briefings followed. Specialists were summoned individually, devices left outside, access restricted. When they emerged, their expressions told the story. Observation requests targeting Mercury were quietly suspended. Raw data transmission was locked down. Then came the most extraordinary directive of all. Webb's active observation mode was placed on temporary shutdown. Inside the restricted network, the images were assembled in full resolution. Mercury's surface, glowing faintly in infrared, revealed something astonishing. Excavation-like grooves traced vast arcs across the planet. In several regions, heat signatures pulsed faintly, repeating in rhythmic cycles. Not chaotic. Not random. Rhythmic. Rhythm implied mechanism. Mechanism implied intent. The pulses did not match any known thermal process. Mercury's interior should have cooled long ago. Yet Webb detected repeating thermal variations, faint but stable, like the residual warmth of a machine long abandoned but not entirely silent. When one team overlaid the data with historical records from the Messenger mission, dismissed anomalies from decades earlier suddenly aligned with Webb's findings. What had once been labeled noise now looked like fragments of a much larger structure. As the implications sank in, concern replaced excitement. If the data were misinterpreted and released too soon, it could ignite panic, speculation, or international conflict. The idea that Mercury might harbor remnants of advanced engineering would upend everything humanity thought it knew about planetary history. The question facing leadership was no longer what Webb had seen, but how, or whether, the world should be told. Then came the hexagon. In Mercury's southern hemisphere, analysts identified a massive hexagonal formation nearly 30 kilometers across. Its edges were defined not by visible rock but by sharp thermal boundaries. It resembled the outline of an immense lattice buried beneath regolith and scarred by eons of impacts. Order where chaos should dominate. Design where randomness was expected. That discovery hardened the decision to pause all further scans. No protocol existed for uncovering possible artificial structures beneath a planet. And no one could rule out the possibility that continued observation might provoke an unknown response. Webb had been built to observe, not to awaken. As the telescope drifted silently in orbit, the burden of understanding fell entirely on the analysts working behind sealed doors, staring at evidence that hinted humanity may have stumbled upon something older than Earth itself. As the shutdown continued, analysis intensified. Teams combined infrared imaging with magnetic field data, geological models, and spectrographic readings. When layered together, Mercury's subsurface transformed from a chaotic interior into something disturbingly coherent. Thermal pathways aligned with ancient magnetic anomalies. Structural symmetries followed planetary stress points with uncanny precision. One revelation stood out above the rest. The thermal pulses appeared to follow logarithmic scaling, a hallmark of engineered feedback systems. In human technology, such systems are used to maintain equilibrium over long periods. If this interpretation was correct, then whatever lay beneath Mercury was not merely a relic. It was designed to endure. Even more unsettling was the discovery that the pulses had grown marginally stronger over time. The change was tiny, almost negligible, but consistent. Something was responding. Whether to solar variation, gravitational influence, or Webb's own infrared illumination remained unknown. The possibility that observation itself could influence the phenomenon forced a chilling reassessment of risk. Specialists from unrelated disciplines were brought in under strict confidentiality. A materials physicist noted that certain temperature zones should not exist under Mercury's known pressure conditions. A signal analyst observed secondary oscillations hidden within the pulses, resembling stabilizing harmonics rather than random decay. A geophysicist pointed out that the structures appeared tuned to Mercury's subtle rotational wobble, responding to it with extraordinary precision. This implied foresight on a timescale that defied comprehension. Whoever designed these structures would have needed to predict Mercury's orbital behavior billions of years into the future, accounting for impacts, solar evolution, and tidal stress. It was engineering not for centuries but for cosmic epochs. Why Mercury remained the most haunting question. Its proximity to the Sun suggested access to immense energy. Some theorized the planet served as an anchor point for harvesting or regulating solar forces. Others proposed it had been chosen precisely because it was hostile and overlooked, an ideal vault hidden in plain sight. As models grew more detailed, a three-dimensional reconstruction of Mercury's interior stunned everyone in the room. Interconnected chambers formed a planetary-scale lattice, distributing stress evenly throughout the crust. At the center, where Mercury's iron core should dominate, the simulation revealed a geometrically distinct anomaly, a layered sphere with faint circulating heat patterns, resembling a stabilizer rather than a natural core. The implications were staggering. Mercury might not simply be a planet. It could be part of a system. Further analysis revealed correlations with solar cycles that appeared predictive rather than reactive. Predictive behavior does not emerge spontaneously in nature. It must be designed. The idea that an autonomous mechanism, ancient beyond measure, could still be adjusting itself unsettled even the most skeptical researchers. Then came the most troubling discovery of all. Subtle harmonic resonances within the data matched frequencies associated with gravitational waves detected across the solar system. Whatever lay beneath Mercury responded not only to the Sun, but to shifts in spacetime itself. This suggested Mercury may once have interacted with something far larger, perhaps other planetary systems, or a network long since fallen silent. The fear no one voiced aloud began to take shape. If the mechanism was still capable of adjustment, what guaranteed its stability? Could it fail? Could it activate? Could Webb's scans have nudged something that had slept for billions of years? These questions justified the silence. Webb remained dormant, its instruments cooled, its operators watching telemetry with mixed pride and frustration. A telescope built to reveal the universe now held secrets deemed too dangerous to pursue without restraint. Inside the secure facility, the scientists worked through the night. Patterns emerged that resembled fractals, repeating across scales like biological systems frozen into stone. Thermal pathways mirrored circulatory networks. Magnetic oscillations echoed neural rhythms. The comparisons were unsettling but impossible to ignore. At last, a preliminary internal report was drafted. Its language was cautious, restrained, almost understated. Yet the conclusion was unmistakable. Mercury contained structures that could not be explained by known natural processes alone. Humanity had glimpsed evidence of planetary-scale design. Outside those walls, the world went on unaware. But within them, the realization had settled heavily. If Mercury was shaped by intelligence, then the solar system itself might be far older and far more intentional than anyone had ever imagined. As Webb waited in silence, one question echoed through every mind involved in the discovery. If something this vast could hide beneath the innermost planet of our Sun, what other secrets might still be waiting, unseen, in the quiet places of the cosmos? If you enjoyed this video, please like and subscribe for more explorations into the unknown. And share your thoughts in the comments. Should NASA have paused Webb's observations after what it found on Mercury, or should humanity keep looking?